Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 8.4.3, which is Circles in Context. Basically, what this chapter boils down to is, how do we use circles to solve for word problems? Well, at the end of the day, when it comes to circles, there are just a few formulas you kind of need to know. And that is, you need to know that the area of a circle is pi r squared. The circumference of a circle is 2 pi r. And that would give you, like we talked about in the last chapter, this gives you the total area and total circumference of the circle. But if for some reason you needed to find the area of a sector of a circle, in other words, a portion of that area, a piece of that area, you would use the angle that was given to you. You would divide that by 360, which is the total angles in a circle, and then you'd multiply that by the area. So again, what you're literally doing is you're taking a fraction of the area. I hope that makes sense. Same thing here. If you're going to do the arc length, well, arc length is, again, it's just a portion of the circumference. So again, you go back to the fraction of the total 360 times 2 pi r. Whoops, that's a horrible pi. So hopefully that makes sense in terms of the things that you need to know. Otherwise, understanding terminology like radius, diameter, that's all going to be commonplace. It's going to be expected knowledge when we move forward with these circular problems here. So with that in mind, guys, let me go and paste the first problem in here. It's 8-100, and it says, while the Earth's orbit or path around the sun is slightly elliptical, meaning ovular, it can be approximated with a circle with a radius of approximately 93 million miles. Okay, part A, it says, how far does the Earth travel in one orbit around the sun? Well, if the sun is here and the Earth is traveling around it, we're talking about the pathway that the Earth takes. Now, if we're traveling around the sun and not occupying any of the space inside in between, because that's being taken up by stars and comets and UFOs and Mercury and Venus and all them, we're talking about circumference. That is what A is asking us to find. So how do I find circumference? Well, that's going to be C is equal to 2 pi times r, which is going to be this 93 million miles. Of course, that's going to require a little bit of a calculator. I'm thinking that's going to be 186 and then 000 000. I guess technically you don't need a calculator. You just need to do 93 times 2. Kick on 6 zeros, slap on a pi, and that's all you would need. And so in this case, it would be in miles. Now, if you needed to actually calculate that out, you really would need a calculator. So I will go and calculate it out for a little bit. This number is approximately equal to 584,336,233.6 miles. So again, that's if you wanted a calculated answer. This would be, the 186 million pi would be exact, the 584 would be decimal. So again, circles in context, that's all it is. We're just orbiting around. We're doing one full orbit. It's not a partial orbit. If we were doing a partial orbit, like when in the episode of Ninja Turtles when Shredder made the Earth stand still, then that would be an arc length. But because we're not operating in the world of Ninja Turtles, we are doing one full orbit. So that's going to be elliptical, but we're going to use circular just to make the problem work. Okay, B, it says approximately how fast is the Earth traveling in its orbit in space? Calculate your answer in miles per hour. Okay, so from here, we know that one orbit is one orbit is 186 million pi miles, and it takes 1 year for that to happen. But they don't want this in miles per year. They want this in miles per hour. So if those of you who have been in chemistry will understand this dimensional analysis problem. What I'm going to do is I'm going to try and convert years into hours. How do I do that? Well, I know that there are going to be 365 days in 1 year, and I also know that there are 24 hours in 1 day. So from here, I know that the days can cancel each other out, and what that means is if I multiply the 365 by 24, I'm going to get 8760 hours per year, which means 1 year can then translate into 8670 hours, and I'm going to carry this big monster number over. In fact, I'll just go and convert them to a decimal again. So 584,336,233.6, and if I divide that physically in a calculator, what that boils down to is it boils down to about 66,705 miles per hour. So if for some reason the H.G. Wells book ever came true, and it was the day the Earth stood still, if the Earth suddenly just stopped on a dime and stopped rotating, a lot of people would be thrown into space because we are living on something that has momentum. So it's actually kind of interesting. I do kind of like that. It's kind of neat. So again, circle in context, right? We found the circumference. We found how fast it was orbiting. Circular word problem. No big deal. I will copy and paste the next one. Give me a second. In 8-101, the problem reads, a certain car's windshield wiper clears a portion of the windshield in the shape of a sector in the shaded diagram at the right. If the wiper pivots 120 degrees during each swing, what is the area of the windshield that is wiped in each swing? Okay, let me put this into a different context. Here's what they want. They want, you can't see that, they want the area of the red shaded piece. But notice how there's this little white piece down at the bottom. They don't want that. So how do we find the area of just a fraction of a sector? Well, what I'm going to do is, I hope this makes sense, I'm going to find the area of the full sector, which is going to be, I'll draw it temporarily, all of this stuff in purple. I'm going to find all of that, okay? So, once I find all of the area of the full sector, that was the thing that I did in purple that I just deleted, then I'm going to find the area of the small sector. Now, what do I mean by the small sector? Well, the small sector is the thing in green right here. And now, unimaginatively, what I'm going to do with the full sector and the small sector is I'm going to subtract them. And that's going to give me the area of the desired sector. In other words, the thing in red. So, let's find out what each of these things is. The area of the full sector. Well, that's going to be, well, remember, if I'm doing the full sector, the radius is 15 and 5, so that means that my radius is 20. So how do I find the area of a sector again? Well, that's going to be theta over 360. In this case, 120 over 360 times pi r squared. Well, that's going to be 1/3, because 120 over 360 reduces into 1/3, times 400 pi. 20 squared is 400 times pi. That means that the area of my full sector is 400 pi over 3. So that's the first piece. Now I'm going to go and find the second piece. Let's go and do this in a different green. Does that match? No, it looks too similar. Let's go and do it in orange. So here's the area of the small sector. So again, the small sector, well, he just has a radius of 5, so r equals 5. Again, the degree of rotation hasn't changed. It's going to be 120 over 360 times pi r squared. So that's going to be 1/3 times pi times 25, which is 25 pi over 3. So again, remember, area of the full sector minus area of the small sector, so that's going to be 400 pi over 3. minus 25 pi over 3. The denominator is already common, so I'm good. 375 pi over 3, which if I wanted to calculate it out, that would be 392.7 inches squared. Inches squared. In other words, what I've just found there is that the area of this darkened place, not including the white space. Oh, whoa, the pen glitched out there. The area of this darkened space, hopefully the pen doesn't glitch out again, minus the white space, is the area that the windshield wiper covers. Hopefully that makes sense. I will see you guys in the next example. And in this last problem, chapter 8, number 102, we're talking about a cookie baker who has an automatic mixer, and it turns out a sheet of dough in the shape of a square that is 12 inches wide. He cuts cookies with a 3-inch diameter in circular cookies, and the supervisor complains that there is too much dough being wasted and orders the baker to find out what size cookie would have the least amount of waste. So the task is to analyze the situation and determine how much dough is wasted when the 3-inch cookies are cut. Then we have to have each team member calculate the amount of dough wasted when a different diameter is used and compare the results. I'm probably going to pass on this portion of the problem because it relies on a bit of a gimmick that makes you determine that as long as you're using a factor of 12, the amount of dough wasted will always be the same. Ultimately, what I want you guys to get out of this problem is how to find the area of the dough wasted. So, from here, hopefully it makes sense that they're trying to get you to get rid of the purple stuff, which is all this stuff in here. We're trying to find out how much of this is remaining. So how do I do that? Well, basically, the full diagram isn't shown because it's the shape is a 12-inch square, right? We know that the area of the square is going to be 12 squared, so 144 inches squared. And then I'm going to find out the area of one of the circles. So remember, if the circle has a diameter of 3, that means that the radius is 1.5. So then that means that the area of the circle is going to be pi times 1.5 squared, or 3/2 squared, which is going to be 9/4 pi. Now that's the area of one of the cookies. But I'm going to multiply him by 16 because if this is a 12-inch square, there should be 16 total cookies in the square. So that will cancel that out, giving me a 4, so 36 pi. And that ends up being the amount of space wasted. 144 minus 36 pi inches squared of cookie dough wasted. And ultimately, that's what these circles in context problems boil down to. Do you know how to use the areas of circles, the circumference of circles, in the context of word problems? So we've done an elliptical orbit one, we've done a windshield wiper one, and we've done a cookie waste problem. Hopefully at this point it makes enough sense for you guys to be able to do these. And as always, you can leave questions or comments in the comments area, and I will see you in the next episode.